Hi, my name is Sandeep Nagar. I am a MSc research student at the Machine Learning Lab, and we are working on automated seed quality testing. We will be discussing about that. So, in our work, we have created a pipeline to just classify all the images. So, first, step is like data acquisition, and the second is fake image generation or image generation. Next is classification, and next is testing and experimentation. So in field of agriculture, manual inspection have had many problem in training consistency and ensuring a satisfactory efficiency, detection efficiency. Here we used computer vision technique for quality check. So in data set, we introduced a new data set and to capture the images we have made a setup in which we have used two cameras, one from top and another second is from bottom, and this plate is transparent, and on that plate we have put that stack of seeds and captured from top and bottom view of both images, and we have uh, we did labeling manually for each images for top and bottom both views. We are considering each image uh, of top and bottom as different image. So in total, we uh, have a different set of instances of each class. And after that, we generated some fake images. So main objective of generating fake images is to introduce network to a different variety of cases, and where like in our case we have a small data set. It contains only 70,000 images. So to increase the diversity of data set, we used generative adversarial network to generate new fake images. So, and there are so many more methods are there to generate images. So here we use DCGAN. In DCGAN, we trained a model for each class. For first we trained a model for broken, and then we created images for the broken class like 2937. Similarly for discolor and pure and fill cut. In next we did classification, and we used transfer learning, and for transfer learning we used the pre-trained weights of image models trained on ImageNet. And like we can see that we use the ImageNet models to classify all the images. Next, steps like accuracy. So we train model without adding the fake images to the data set, and after adding the fake images to the data set, as we can see here, there, there is like 18% plus difference between validation accuracy of before and after adding the fake images. And to test this model, we capture image of a stack of seeds, and we give as an input to a masked RCNN model, in which this model will give a each image each image of each seeds, and each seed will be individually given as input to the classification model, and that this will predict a level for each of the type of the each of the image of stack. And this way we can find out like how our model is working and like if we are getting really good accuracy or not. So and we also uh, try to find out like the confusion matrix. So like is there like a one-to-one mapping between image and class, or there's some confusion between two classes? So here we can see like there are some classes which may like the image may belong to more than one class. So for each classes we like have like more than 80% accuracy, but still there are some confusion in that. So and the application step of this you can like say that there are different application of this uh, the method we have developed model. So this can provide a solution to the farmers, and we can implement some other uh, crop image and use as to do some testing of that crop like how is crop growing, and we can keep an eye of the crop if there is something else, then we can notice that and take accordingly actions, uh, like monitoring the growth of crops and finally like classification of the crop, and we can just do single images and take as the input, and then we can say that these are like changes, and accordingly we can take some action. That's all. Thank you. If you have any doubt, please reach out.